Today's lesson is about trigonometry, and it covers section 7.1, or sorry, not 7.1, 7.5 and 7.6 together, and a little touch of 7.7. 7.7 is more real-world problems. So once again, the term is trigonometry. So the key thing you got to be able to focus on is this shape. You need right triangles to use basic trig. Without a right triangle, you can't use basic trig operations. There's some more advanced things you can do with trig later on that you don't have to use right triangles, but for now, we're going to say you have to have right triangles. The other thing is you usually need to focus on one particular angle at first. So traditionally, you look at one of the two acute angles. So let's just pick this angle over here, and I'll just put a little mark, and I'm going to put this little symbol over here, and that's the Greek symbol for a theta. Sometimes they'll throw in other Greek symbols like alpha, and I think that one's gamma, but occasionally you'll see that in algebra and higher level math classes. Don't be tricked by them. It's just another representation of a variable. So once you have noted where an angle is, you can then label your parts of your triangle. And the words that we're going to use to label are words like hypotenuse, opposite, and adjacent. So I think always the hypotenuse is the easiest. On this picture, where's the hypotenuse? It's the longest piece. It's across from the right angle. Hypotenuse should always be the easiest to find. After that, we have two words, adjacent and opposite, we have to deal with. Adjacent is pretty easy if you understand what the word means. Does anybody know what adjacent means? Right next to it, side by side. So adjacent is the side right next to the angle. Well, obviously it's not going to be this one, so it's this one over here. This is the adjacent side. It's right next to the angle. The other word we're going to use is opposite. Opposite is pretty simple. It's across from the angle you marked. It's the furthest away. So there's my side that's opposite the angle. So one more time, we have hypotenuse, adjacent, and opposite. So you may be thinking, why is this important? Well, these are important to be able to use trig ratios. There are 3 trig ratios you should be able to use. And they kind of relate to these things you should see on your calculator. You've probably seen this before on your calculator. Sin, cos, tan is how a lot of you say it. But those are actually abbreviations for words. Does anybody know what this first one abbreviates? Sine. It's S-I-N-E. Sine. We don't say sin, we say sine. Anybody know what this one is? Cosine. We do not say cos, we say cosine. And the last one? Good try. Not tan sine. Tangent. Sine, cosine, tangent. We don't say the abbreviations. We say the real words. You look silly if you say some of those abbreviations. And along with that, we have an acronym that's pretty famous for trig ratios. You might have heard of this before. And it's pronounced phonetically. SOHCAHTOA. SOHCAHTOA. It's pronounced phonetically, so you can say SOHCAHTOA. And this helps you remember the 3 trig ratios. The first one deals with sine. Sine, you can write the abbreviation, but when you have sine of a particular angle, so we'll say sine of some angle, in this case we have theta. Sometimes they'll put a letter there like angle A or something. But in this case, it's angle theta. Sine of angle theta deals with these 2 letters, O and H. Well, what does O represent? O represents opposite. So opposite goes on top. So whatever comes first after sine goes on top. The next letter is h, and h is representing hypotenuse. The ratio for sine is opposite over hypotenuse. Sine is opposite over hypotenuse. Cosine is done the same way. We're going to do cosine of theta. Cosine deals with a and h. Well, what did we say a represents? Adjacent right here. So we're going to have adjacent on top and h on the bottom again. So there's two of the three trig ratios. Now we have one more. The third one is tangent. Tangent has O and A. We already said O. What's that? Opposite. And A goes on bottom. That's adjacent. Those are our three trig ratios. So the key thing is to be able to apply trigonometry to different situations. So I have a little worksheet. Here's what it looks like. It has basic trig, and then it gets a little more complex, and then it gets basic again, and then a little more complex. So the first ones are really basic, but I want you to focus on just the evens right now. We're just going to do the evens right now, so focus on those. Now this one is pretty simple. However, it doesn't give you it doesn't give you a picture of a triangle. When it doesn't give you a picture, you don't need to do all the labeling and stuff. You just need to look at it and think about it for a second. This gives you an angle, and it gives you trig. Anytime you have both trig and an angle, you can type it in. So on your calculator, you can hit the cosine button, type in 73, and then hit enter, and you're going to get a decimal. And it says it wants the decimal rounded to the nearest 10,000. So tell me what that answer is to the nearest 10,000. That's 4 places, if you've forgotten. So you get 0.29. What's the rest? 23 or 24? So make sure to round properly. This is a rounded answer, so we're going to use the approximately equal to symbol. Write this note somewhere on your paper. When they give you trig and an angle, type it in. When they give you trig and an angle, and that's exactly what they do, you can type it in the calculator, and that's all good. The key thing, make sure to give a lot of decimals because sometimes we'll have to do some rounding at the end. Trout number 4. Try to type in tangent 56 and press enter, and tell me what you get there. 4826 is what I heard. 1.4826. There's your approximation for the tangent of 56 degrees. Those are easy. Those are easy. Now down here on number 6, it's different. Number 6, they don't tell you tangent and an angle. So you can't type this straight in. So what we're going to do is we're going to label the triangle like we did earlier. First thing you got to focus on is an angle. And it tells you which angle to focus on. It tells you tangent of angle A. So we're going to put our little angle mark in angle A. Don't worry about putting theta in there. As long as you have an angle mark of some type, you're good to go. And from angle A, we're going to label our sides. Hypotenuse, adjacent, opposite. We're going to label our sides. Which one's the hypotenuse?
41.
41. It's the longest. It's across from the right angle. Which one's the adjacent? 40. It's right next to the angle. And the opposite one is the one that's furthest away. That's the 9. It's across from the angle you're given. Now you need to think, what was that ratio that dealt with tangent? Remember, it says tangent right here. All right, so you got to remember, you're going to be dealing with opposite over adjacent. So that's what we're going to write. Please write this out. Tangent is going to be 9 over 40. So tangent of A is 9 over 40. But once again, it wants the answer rounded to the nearest 10,000. Is this fraction rounded properly? So we're going to have to round this fraction. 9 divided by 40 is what we need to type in. 0.2225, and it stops?
Yeah.
All right, so don't worry about any more after that. There's your answer. If you want to put a 0, that's 4 places, that's good. I probably wouldn't take off if you forgot the 0. So once again, this part, we just divide. Did I touch the tan button? No. So on this type of problem, we don't touch the trig. These are key facts. These are key things that I've seen over time. People will type in something after tangent. They'll type in tangent something and get a wrong answer. This kind of problem, you don't type it in because you don't have trig and an angle. That's the key concept there. Number 8's really similar, except this time they ask for sine of A. So what's our first step? We mark angle A. Tells us angle A here, so we mark it. We put our little angle symbol inside A. You could put theta if you wanted. And then we got to be focusing on sine. We got to remember the sine ratio. Sine was what over what? Okay, so where's the opposite? 7. And then opposite over where's hypotenuse? 25. These are the two pieces I need to be focusing on. I don't really care about the adjacent. So once again, I need to put opposite over hypotenuse. That's 7 over 25. And since it said round, we need to round this answer. 7 divided by 25 is 0.2800. So one thing pointed out, this doesn't have to be approximately because it's exactly 0.28. So you could just do the regular equals. If you put approximately, I wouldn't take off for that. Just trying to teach you what's proper. If you just put 0.28 and forgot the zeros, I wouldn't take off for that. Just the 2 zeros would be more proper because it said round to 4 places. Down here, this one says a different question. Number 10 just wants the trig ratio. What's a ratio? A ratio is a fraction. It just wants a fraction. It doesn't want a rounded answer anymore. So that's what we're going to do. First thing, it says sine of A. First step is marking angle A. Sine is what over what? Opposite over hypotenuse. So I need to mark my opposite side. Where's opposite? Yes. And where's my hypotenuse? 45. Those are the two pieces I need. From there, I can write my fraction. 36 is our opposite, and 45 is the hypotenuse. We don't like to leave unsimplified fractions, so go ahead and simplify that one and tell me what you get. No, not decimals. I didn't say divide. Simplify the fraction. 4/5. We want the simplified fraction. Simplified fraction. Number 14 is the next important one to focus on. It's different than what we've seen. This one, they give you an angle and a side. You're missing another side. You're trying to solve for x, but it's still using basic trig. The angle they want you to focus on is already marked with 26 degrees. So we're going to put our angle symbol there. Oops. Try that again. We're going to put our angle symbol there. And we're going to label from that angle that they marked. What's this 16? What do we label that as? Hypotenuse. It's the longest. It's across from the right angle. What do we label the x with? Adjacent. It's right next to the angle. It is side by side with the angle. But now you need to think to yourself, which trig ratio deals with hypotenuse and adjacent? Cosine. Cosine. So this deals with cosine, and here's what we need to write. We need to write Cosine, we can do the abbreviation. Earlier, we didn't know the angle, so we had to put a variable or a letter or something. But now we know the angle, so we can write in the angle. It's 26. And on the right side, we still do our good old fraction like we've been doing. Remember, cosine is adjacent over hypotenuse. Adjacent is x. Hypotenuse is 16. Next up, we're going to be trying to solve for x. So I'm going to teach you a basic way. It's not the most accurate way, but this way will work. This is probably a simple way. What you need to do is realize that this part you've already done before. You've seen trig and an angle, and what did we do earlier when we saw trig and an angle? We typed it in. So type in cosine of 26, enter, and give me those 4 decimal places again. 8. 8, and that's rounded properly? Okay, so giving 4 places is good here. And then we're going to just bring the other side down. I didn't really do any math other than typing that piece in. Remember, you can always type it in when you have trig and an angle. But the question is, how do you solve for x? This is algebra. How do you solve for x? Okay, so multiplying by 16 will work. Another trick I want to show you is, this looks weird to a lot of people. But if you just do this, now it should look very familiar. What did I just create? A proportion. And you should be awesome at solving proportions because all you do is cross multiply. And that reiterates the fact that you're going to do 16 times that decimal value. So tell me what 16 times that decimal is. 3808. And that's approximately equal to. And always double check. Does this number make sense? Well, that's hypotenuse. This should be a little shorter. Is that a little shorter than 16? Yes. There's your answer. Now, one problem. This is rounded to 4 places just like this was, but it says it wants the final answer to the 10th. So I don't want this part to be 10th. I want the last part to be the 10th. So that chops it right here. Does the 8 round up the 3? Yes. So I want to change that 3 to a 4. And now it's more appropriate to what the question's asking for. Now, another thing I want to point out, if you do round short here, it might cause a slight rounding error there. Another better way would be to just do cosine of 26, press enter, and then times by 16. Try that real quick. Try cosine of 26, and then multiply it immediately by 16. Tell me what you get for that answer. 14.3807. So did it matter a whole lot? Once again, we're chopping there. Oh, sorry, wrong spot. We're chopping here. Does that round that up? Yep, another 4. Did we get the same answer? Yeah, we got the same answer, but that last couple decimals over here, the 4th spot, they were off. So rounding a whole bunch could throw it off in the end, but just keep that in mind. I'm going to give you a second now to try out number 18, see what you can do. On number 18, we got to do the same process as we did earlier. What we first need to do is figure out what angle they're talking about, and there it is, 54. From there, we label what we know. This is the opposite side. This one right next to it is the adjacent side. We got to remember which trig ratio deals with opposite and adjacent. That's tangent. So anytime you know the angle, you need to plug it in. From there, we can focus on how to set up that fraction. Remember, it's always a trig ratio on that right side. Let's see. The top, what do we put there? 19. It's opposite over adjacent, so it's 19 over x. So earlier, we talked about if you have trig and an angle, you can type that in. When you type that in, you get 1.33764. That equals 19 over x. And remember, this is kind of funny looking for some people, but if you put it over 1, it's really familiar. We have a proportion now. Now we can cross multiply. So on one cross we have 19. On the other cross we have 1.3764 times x. So to get x alone, we divide by that 1.3764, and we get x is approximately what? I heard 13.8. Do we all agree? Good. Number 26 is the next topic we need to discuss. And I want you to write this phrase somewhere. When you don't know the angle, you use the inverse. So write this phrase again. Come on. There we go. When you don't know the angle, use the inverse. So inverse is the key word, but it's probably kind of abstract to you right now if you don't know what I'm talking about. So all these trig ratios have inverses. It's kind of like working backwards, we'll say. So all we have to do is type in tangent inverse, it looks like that on your calculator, and then type in the decimal. And we get our answer. Type that in real quick. Remember to do inverse, sometimes you'll have to do second because it's in blue. So a lot of you told me you got something like 25.998 something, but remember this question says to the nearest degree. So rounded to the nearest degree, it's approximately 26 degrees. So for your work, I want to see this right here. I want to see that you remember to do tangent inverse of that to get your correct answer. Try tangent of y real quick. It's pretty easy. All you do is tangent inverse, type in 0.2309. All right, it looks like it rounded to 13 degrees. So that's the work I'd want to see. The next topic is down here on number 30. Number 30, it gives you all the sides, but it doesn't give you an angle. It wants you to solve for a missing angle. So here's that missing angle. It's already marked. From there, you need to be able to label. So you got to be able to label your triangle from here. Where's my hypotenuse? Okay, there's my hypotenuse. It's across the right angle, longest side. Where's my adjacent side? 39. It's right next to it, right next to our angle. And then our leftovers are opposites, all the way across from the angle. It's on the opposite side of the triangle. Now, the problem here is, how do you know which trig ratio to use? Well, the truth is, it doesn't matter. Since they gave you all the sides, it does not matter which trig ratio you do, as long as you pick the correct sides. So on this one, I could use sine, I could use cosine, or I could use tangent, as long as I use the inverse and I pick the correct sides. Remember, I use inverse because I don't know my angle. So I'm going to try out sine inverse over here. For sine, what sides should I use? Opposite is 52 and hypotenuse is 65. Type that in and tell me what that approximates to. So we get 53 to the nearest degree again, to the nearest degree. If you go over here now and try tangent inverse, what sides should tangent use? Opposite and adjacent, that's 52 over 39. Type that in and you get 53 again. So once again, it does not matter which trig ratio you use when you're given all your sides in this situation. But you still got to remember to use inverse and pick the correct sides. Do you have to use both of these, sine and tangent? No. One of them is enough. So if you would have just done this one right here, you're good to go. Number 35 is not quite as generous. On this one, they give you only two sides, and you're missing an angle. So on this one, you have to figure out which trig to use. So how do I label this piece? That is number 13, the angle. Okay, that's adjacent. And number 22, it's our hypotenuse. Hypotenuse and adjacent, look on your little cheat sheet right now. And that's cosine. Remember, to solve for angles, we use the inverse. And that's 13 over 22. Round that answer, and what do we get? 54.